both the cases that I plan to explain were in the field of supply chain management. That is, how can we apply, or what kind of analytics techniques can we apply in the field of supply chain management. Now, just to set some context here, what comprises the supply chain? So the supply chain, if you see, is the set of activities which help you take the product from the factory where it is manufactured to the customer. Okay. Now, what are those activities? So the first step in any supply chain, in any industry, is to forecast the demand. How much of our products are our customers going to buy? So that we have estimation of that demand is the first step. And once that is estimated, we buy the appropriate amount of raw materials so that we can start our manufacturing process. And once we have the raw materials in our hand, we transform those raw materials into finished goods. So that is the actual manufacturing or the processing activities that take place in the factory. And once that is completed, we distribute those finished goods to the customer by way of transporting from the factory to the retail stores and further on to the doorsteps of the customer. So that is the final stage, which is we are saying as the distribution stage. Now, in each stage of the supply chain, there is a potential for analytics. And what kind of potential is that? That is what I have listed at the bottom. So where I'm saying, in the demand forecasting stage, analytics helps us to achieve a higher forecast accuracy at a SKU or day level. SKU is nothing but a stock keeping unit, which is the lowest granularity at which we actually take stock in our warehouses or in our retail stores. Anywhere, if you see, regular audits take place, and these audits happen at the SKU level. So for each product, each SKU, how many units do I have? So that is my stock, and if I am to forecast, improve the forecast accuracy of the stock, I can use some advanced analytics techniques. So that is where analytics helps in the first stage of the supply chain, that is demand forecasting. And then if you come to the next stage, where we have to buy raw materials from our suppliers or vendors, then it comprises a range of activities in itself. So starting from better negotiations for prices, and then vendor performance tracking, incentivizing the vendors to give better services to us, and then drawing up the most optimal contracts with our vendors. So in all these places, analytics can help. And the case which I'm going to talk to you about today is in this area, by procurement of the raw materials. And once I procure the raw materials, I will transform my raw materials into finished goods. So this way, I said, right, this is the actual manufacturing activity that we do on our factory floor. And here, how does analytics help? Now, this is where we talk about Industry 4.0. How many of you here are familiar with that term, Industry 4.0?
Me.
Yeah, me.
Yeah,
So engineering course, we will have all this.
Sorry, Jairam, I didn't get that.
So, like in mechanical, we have an industrial engineering course in which we will have, in which we will get familiar with all those terms like Industrial 4.0 and supply chain management, all those.
Right. Yeah. So Industry 4.0 is where the entire industry or the manufacturing process has been revolutionized by the introduction of this new technology called as Internet of Things. So every machine that you see today has sensors fitted onto it, which help us track the real-time status of any particular machine. So these sensors feed in continuous streams of data, which helps us in preventive maintenance. And in today's Industry 4.0 narrative, preventive maintenance is slowly moving towards predictive maintenance. So using the sensor data, we are able to actually predict when the equipment needs maintenance, when it is going to possibly fail, that sort of thing. And also, again, with the help of these sensors, I can track each and every person on my shop floor or in my warehouse. What is he doing? When did he log in? When did he log out? At any given point of time, where is that particular person? So now all these activities I can track using my sensors. So this third stage, where I'm transforming raw materials into finished goods, this is where Industry 4.0 and the technology enabled by Internet of Things plays a very, very important role. Now, next stage, the final stage, if you see, it's the distribution of the finished goods to my retail stores and possibly to my customers. Now here, when I'm owning a large fleet of vehicles, now in order to run a very efficient supply chain or efficient last mile operations, I need to plan my fleet management activities accordingly. So here we have certain algorithms. like you have something called as a Clark rate savings algorithm, which will help you decide what routes to allocate to what vehicles. So if you have, let's say you are running a school, right? That school will have some 5-6 buses, which will have to cover some 10 or 15 areas in the city. So what areas will be allocated to what buses? So that so this Clark rate savings algorithm helps you decide those particular areas by way of a heuristic method. That is, so which is that particular route which helps you reduce the cost. So there are some algorithms available for this as well, and so this is how analytics helps you to optimize or improve or achieve performance enhancements in each stage of the supply chain. Just to set some context and explain this. Any questions here?
No, not from my side.
Yeah.
Okay, let me just move on. Okay, so this case which I'm talking about, the spare parts procurement case, and this was involving the company Caterpillar. So Caterpillar, see, they manufacture trucks, bulldozers, earth-moving equipments, and the like. And 5 years back, I'm sure you must be familiar with this website called Kaggle.com, and they had crowdsourced a particular problem that they were facing, and so I was working with Cyient Limited at that time when we were also consulting for Caterpillar. So they said, why not take a shot at this competition as well? So the case that I am going to talk about, I'll talk about what I did as part of working in that particular competition, Kaggle competition. So again, before starting on any project, it's always important to understand why are we doing that particular project? How is that project or how is that particular business activity important to that company? Okay. Now, I told you, right, this is related to the second stage of the supply chain where we are procuring raw materials from vendors or suppliers. Now, why is this procurement so important? I mean, so at the high level, if you see, I mean, it is just I'm buying something from someone and I'm paying some money for that and I'm getting decent quality products. But why is this? What makes this activity so complicated? So, for example, if you see for automotive companies today, procurement makes up 80% of the total cost. So why does this make up so much of my entire cost? For example, I'm sure you will be familiar with the Maruti Suzuki Swift, right? Do you know what is the engine that goes into the Maruti Suzuki Swift? I'm not talking about the current BS6 era. I'm talking about a few years back. Until a few years back, do you know what was the engine that was used in Maruti Swift? Anyone, any idea?
No.
Okay, it was actually a Fiat engine.
Okay.
It was not a Suzuki engine, it was actually Fiat engine. So why did Maruti Suzuki take this decision of buying an engine from someone else? So engine, if you see it is, if you compare the car to the human body, you can consider the engine as the heart of the car, which is the most important part of the car, you can say. But that most important part, Suzuki did not manufacture it themselves, they bought it from Fiat. So the 1.3 liter turbojet engine was purchased from Fiat. So why did they do this? So that is why see the next point. For companies today, the core competency is not manufacturing, it is design. This is a very, very important point that we have to understand. Okay, and the best example for this is Apple. So Apple, if you see, anyone who owns an iPhone, they'll know. You take the iPhone, you look at the back surface of the iPhone, it will say designed by Apple in California, made in China. Now all the phones that we have today, all the smartphones that we have today, Oppo, Vivo, OnePlus, Apple, Nokia, whatever, all the phones that we have, all the smartphones, everything is manufactured in China. But from my experience and from the experience of a lot of other people, Apple beats most of the other brands in terms of the reliability, in terms of quality, in terms of the ease of use of the user interface. In all these terms, Apple beats its competitors, and that's why it's so expensive as well. But still, Apple is also manufactured in China. All the OnePlus, Oppo, Vivo, everything, they are also manufactured in China. So what makes the difference between Apple and the other brands? It is purely the design. So that's why companies today, manufacturing is available everywhere, especially low cost manufacturing. You take a country like China or Thailand or Vietnam. So all these Southeast Asian countries are very, very competent in manufacturing. So today, the thing that gives companies a competitive advantage, or the thing that sets companies apart from its competitors, is the design of its products. And even you might remember a few years back, there was this court battle between Apple and Samsung. So Apple sued Samsung because they said Samsung user interface is very similar to that of Apple. So finally, the court ruled in Apple's favor, and Samsung had to pay some millions of dollars in fine to Apple. But today, if you see, the glass, the front glass in the Apple iPad is manufactured by Samsung. So though Apple and Samsung are business rivals in some sort of way, Samsung is the provider of the front surface glass for Apple iPad. So why do they do that? Because Apple knows that when it comes to the glass, Samsung is the best in terms of manufacturing, and they want to have the best. So that is why they have outsourced this critical component manufacturing to Samsung. So, when companies are increasingly outsourcing the manufacture of their critical products to other companies, that's why we are saying there is this increased need for procurement. Okay, and in this procurement scenario, if you see many items, many suppliers across geographies, which leads to many intricacies in the pricing. And one classic example here, to take the Boeing 787 Dreamliner aircraft. Okay, so just look at this picture. Each part of the aircraft is manufactured by a different supplier in a different company, in a different country. So looking at this picture, it looks like something like a brochure for a world tour. You have Korea, Japan, Australia, Canada, Italy, US, Sweden, UK, France. You have so many countries manufacturing so many components. Okay, and so what does Boeing do? None of these parts are manufactured by Boeing. Okay, all Boeing does is, Boeing has a factory in a place called Seattle in Washington, and Boeing just puts these components together, slaps on their label of Boeing 787 Dreamliner, and sends the aircraft to customers. But all the components are procured from outside suppliers, and these suppliers are located all over the world. So when I'm having to procure so many items from so many suppliers in so many countries, and when I'm procuring large quantities of items, I need to be very, very cautious about the price that I'm paying. Because again, if you see, for automotive companies, procurement makes up 80% of the total cost, which is a huge chunk of my P&L. So I have to be extremely careful when making my purchasing decisions. So for example, if you see this scenario, when a supplier quotes $3 per part, how do I know I cannot get it for $2.50? I need to have a very, very accurate estimate of the price that would be quoted for a particular part. Only then I can negotiate very efficiently with my suppliers, so that the supplier doesn't get the better of me, and I get economies of scale when I'm purchasing parts over huge quantities. So that is where procurement becomes very, very important in today's business scenario. And I think the core thing that we have to take away from this slide is this point: core competency is not manufacturing, it is design. And there is this huge trend where companies are outsourcing their procurement and other manufacturing activities to someone who is capable of doing it better. So this is a very important trend that is shaping business today, and this will also help us understand why is procurement so important in today's business scenario. Any questions here in this slide? Right, okay, let me just move on to the next one. Right. So what was the activity done in the Caterpillar price estimation project? So this one, if you see, it is a typical straightforward machine learning application. And here, like I said before, the situation was that we have to estimate the price a supplier would quote for a particular spare part. So like I said here, right? So when a supplier quotes $3, so tomorrow I'm going to a supplier and I need to procure some part A, okay? And that supplier is saying, hey, this part A, I will sell it to you, but you have to pay me $3 per part. So how do I know I cannot get it for $2.50? So I need to have some estimate or some calculator with me. And what we have to do is we have to build that calculator. So how do we do that? So that is where the machine learning algorithms and all these techniques help us, and using that machine learning algorithm, we will estimate the price a supplier would quote for a particular spare part. Now the data in this scenario, we had around 21,000 parts which were procured from 8,000 suppliers, and then using this data, I'm sure you will all be familiar with the typical machine learning activity, right? So we have something called as a drivers or the independent variables which have an influence on the dependent or the target variable. So what are those drivers in this particular project? So the first, for ease of understanding, I grouped those drivers into three categories. So one is the part type, next one is the forming process, third one is the miscellaneous features. Now part type, people who are familiar with mechanical engineering, I think they might have some resonance with these terms. So we have couplings, we have seals, sockets, flanges. So these constitute around 70 features. Then we have the forming process, which denotes how exactly was the part manufactured. So whether it is done by welding, whether it has a rivets, whether it's a fitted part, whether it's cast iron, or whatever. So like this, there were around 9 features. And then certain miscellaneous details. So surface area of the part, volume, weight, density, 11 features. So why do we use all these features? So this is why I'm saying domain knowledge always helps. Okay. So the price for a part will be determined by the manufacturer based on part material specifications, order quantity, labor, other costs of production, like that. So for example, part material, right? It might be cast iron, it might be mild steel, it might be aluminium. So if it's aluminium, it's lightweight, which means it is more expensive. But unfortunately, if you see, our data does not specify the exact material of the part. It doesn't say whether it's iron or aluminium or steel or whatever. So, but we have the dimensions using which we have the dimensions, we have the weight, using which we can calculate the density. So this density, we can consider it as a proxy to the material. So each material or each metal type will have a particular density, and that metal type has a bearing on the final cost. So this is how we convert some qualitative data or a non-quantifiable data into something in which we can quantify. So part material is something that we don't have available, and even if it is available, it is a qualitative information. But how do we transform that qualitative information into quantitative information? We form features. So volume, weight, density. So these are the miscellaneous features, and these details were provided in the data itself. In the forming process, part type, so these were directly provided in the data, and so these features are essentially proxies for these domain knowledge features which I have listed here: part material specifications, and of course order quantity. This was also provided in the data itself, and of course it is not possible for us to factor in every available driver of the price. There might be a certain other costs of production as well, which we don't know currently. But with the features that we have, we make an estimation using a machine learning model. So what is the machine learning model that we built? So we had a combination or an ensemble model. So we had one random forest model, and then we had one extreme gradient boosting or XGBoost model. And when I say ensemble, what it means is, let's say, so there are two models here, right? One is a random forest and one is XGBoost, and each model will give one particular output. So let's say random forest estimates $2, extreme gradient boosting estimates $3. So the final estimate will be 40% of the random forest estimate and 60% of the XGBoost estimate. This is because each model is good at predicting some values and not good at predicting some other values. So in order to strike the right balance in the accuracy of the model, we use this weighted average approach or the ensembling approach, which takes a little bit from each of the models. So whichever model is having somewhat a higher accuracy, for that we give a higher weightage. So in this case, the XGBoost model had a higher accuracy. So for this, we gave a weightage of 60%. And for the random forest model, we gave a weightage of 40%. So this is how we given to the final estimate of the price. Now, how do I actually use this model in my day-to-day life? So let's say I'm working in the purchasing department of Caterpillar, and I am responsible, or I have been entrusted with the responsibility of procuring some 21,000 spare parts from 8,000 suppliers. So how do I use this model? Because I know that my boss will ask me tough questions if I waste the company's money, right? So how do I use this model to get my make the right purchasing decision? So what I do is I get the part details. So all this that you saw here, right, with the part type, the forming process, surface area, volume, weight, all these things. So I will get all these details. I will feed all these details into my model. I will get the price estimate, and using this estimate, I will negotiate with my suppliers for better prices. So the next time the supplier quotes a price which is way higher than this estimated price, I know that the supplier is trying to take advantage of it. So that's what I will. So I will use this estimate to get better negotiations with my suppliers. And so this whatever I said is a base, or the high-level overview of the modeling activity. And there are certain ways to enhance the model as well. So one way to enhance is feature engineering. So like I said, if you have the material directly, it might give you some kind of an accuracy, which might not be the most optimal level of accuracy. So how do we improve, or how do we get more information out of the available data by way of feature engineering? Where I said, using the dimensions of the part, I will calculate the surface area, volume, weight. So these are all additional features that we have generated out of the existing variables, which will help us improve the model accuracy. And then feature reduction. So if you see here, there are around 70 features of the part type, 9 features of forming, and the 11 features of miscellaneous variety. But out of this, all features might not be very relevant to us. So what I did in this project was I used a technique called as principal components analysis, which will essentially reduce your entire feature list to only those features which are having a bearing on the final output variable. So only those which are having a significant impact on your target variable, those will be the features considered. So this is one more technique which helps you to enhance the accuracy of your model. And then also you have the cross validation. So here what I did was I used a 5-fold cross validation approach, which is nothing but within this training data that we have, right? The model or the algorithm takes 5 random samples, and each time it takes sample, it splits that sample into a training data and test data, and it fine tunes itself by training on the training data, and it applies that model on the test data, checks the accuracy, and based on the accuracy, it fine tunes the its parameters and gives the best possible configuration of the model. So that is the cross validation. And ensemble, I told you. So one feature or one particular model might not give the best result. So we use a combination of 2 models and use a weighted average, which will help us get the most accurate estimate. So these are all certain techniques which we can use to enhance our models. Any questions here?
No.
Sai, I have some question here. So
Yeah.
for example, you have told that flange all those, right? In that actually different machining process will be involved, and like each machining process will have different costs. Like how did you interpret all those? Just I'm trying to understand. Yeah.
Right. So that we were not able to interpret directly. So for example, I have put here labor and other costs of production, right? So this was something that they did not give. So we had to make do with these features only. So so that's why I use the word proxy, which is not a direct variable or direct correlation with the exact thing that we are looking for, but something which helps us explain. So for example, the cost of a coupling might be higher than the cost of a flange, but since we don't have those costs directly, we can just input. So what we typically do is we do a one-hot encoding, right? We convert this into a binary variable. So I will in my data set, I will have one column for coupling, one column for seal, one column for socket, and under each of these columns, I will have a value of either 1 or 0. So if it is a coupling, then it will be 1. Under coupling column, it will be 1. For seal and socket, it will be 0. If it is seal, then for coupling and socket, it will be 0. For seal, it will be 1, like that. So these features we were able to use directly since we did not have this labor and other costs of production.
Okay.
So I have a question. Like as you said, like instead of using part material, you are using density, right? So let's say you manufacturer is using two different materials, which got two different densities. So as you see the overall density, that will be different, right?
Yes.
So how can you accommodate that?
So that is something that this particular model cannot accommodate, and I think this situation where we were dealing with, right, everything was made of only one material. So for example, coupling or seal or socket, I think whatever parts that we had were having only one material. So based on that fact, we were able to use this as one of the variables. But yes, whatever you said is a valid point. In case it is made up of two materials, then what we have to do is so those two materials will be assembled together, right, or they will be put together in some way, and what you have to do is you have to calculate the density of that first part, and then calculate the density of the second part, and then add them up or take an average or do something like that. That's the way to do it. But here, since everything was of the same material, we didn't have to do it.